Hello, let's look into today's Leetcode problem. Maximum beauty of an array after applying operation. So you are given with a zero indexed array nums and a non-negative integer k. You can perform an operation, and that operation is choose any index from the array that hasn't been chosen before, okay? From the range 0 to nums of length minus 1. Okay, so basically you can choose any index, but whenever you choose an index, you can perform that operation on that one index only once. And what is that operation basically? So you can replace that index value with any number which ranges from this to this. So for this example, let's say if we take 4, then 4 can be replaced by um, 2, 3, 4, 5 and 6. So 4 minus 2 is 2, 4 plus 2 is 6. So the range will be from 2 to 6. So any number can be filled in this place of 4. And once you do an operation on 4, you won't be able to do any other operations once again on that index 4. Okay. So the beauty of an array is length of longest subsequence consisting of equal elements. So what they want us to do is do some operations in this given integer array and try to form a subsequence that has um, equal elements. So that subsequence should have all the elements of same value. All of the elements should be equal. So that's what they want us to do. So for an example like this, so what they have done here is they tried to change 6 into 4, then they have made 2 into 4. So that's what they did here. And the longest subsequence that can be formed for this example will be 4, 4, 4. Removing this, neglecting this one. Subsequence is basically, something in a sequence but not continuous, basically. Any substring or subset in a sequence but not continuously. We can term it that way. So here the subsequence that we form is 4, 4 and 4, and its length is 3. So we need to return the maximum possible beauty of an array. Beauty is basically the longest length of the, maximum length of the longest subsequence that we can form. The longest subsequence that we have formed here is 4, 4, 4, and the length is 3. So that is what we will be returning here. And for this question, the length is 4 because here the value of k is 10, though we might not need it because already we have all the elements in an equal value. So that's the reason here the value is 4, because this complete array is the longest subsequence that is beautiful, or whatever you may call it. Okay, so this the approach for this problem might be a little tricky, but the solution, once you get to know about the intuition, right, then you will be able to code it by yourself. I can guarantee you that. So, and the tricky part is actually, if you have come across this question, then well and good. If you haven't, then for me, I had to take an hint, and after that, I was able to think about the solution. So, here, what they want us to do is find a subsequence, and that's in that subsequence property that we might notice here is, here the subsequence is 444. So here it doesn't matter, like no matter how you arrange the elements in any way, right, you will be getting a subsequence that has equal values. So by that, what I mean is, I'll just take this example and we can walk through it so that we get a better understanding on what I'm trying to say. Okay. So here ultimately, after doing some sort of conversions, doing some sort of operations, 4 will be treated as it is, 6 will be converted into 4, 1 will be converted, it won't be converted, 2 will be converted into 4. Now let's take another possibility, right? Let's try to juggle up this array, and in this case I simply sort the array. By sorting, I mean 1, 2, 4, and 6. And I do the same operations. One won't have any conversion. Uh, 2 can have a good conversion, which will lead us to 4. 4 remains the same. 6 gets converted into 4. And this scenario as well, we are getting a subsequence of maximum length subsequence, and here also we are forming a subsequence with same element. The subsequence here is 4 4 4. Here also it's 4 4 4. So one thing that you should observe is no matter how the positions are for an array, we will be getting the same subsequence. That is only because the subsequence values are all same. If it were for a question where you want to find a maximum, like let's say increasing subsequence or decreasing subsequence, then we would have had to take care of, we should have taken care of the ordering also. But for this question, as the subsequence has all the values same, so ordering doesn't really matter here in this question. So we take advantage of this point and we do a sorting. After doing a sorting, right, we are simply going to apply a simple sliding window protocol to get our answer. That's it. So what I did for this solution is, after I do the sorting, I will keep two pointers like a regular classic sliding window. Ith pointer pointing here, jth pointer pointing in the same location initially. I do the iteration. Let's say I do a for loop on j, or j is a constant iterator, I would call it. So in the beginning, I will check if I and j are equal. If both of them are equal, then we can simply proceed forward. That is one thing. But if both of them are not equal, let's say j is in this position, I is here and j is here. So in that scenario, actually we can come to a value where j can be converted back to I. So to so because here right now k's value is 2, so so we are in range 0 to 4. So j can be converted back to 1. This position can be converted back to 1. So the condition that we can write is like, if we can if I is equal to j, or let's say if j jth index minus ith index value, jth index values minus ith index values lesser than or equal to 2 times of k. If you didn't understand this formula, then let's try thinking of it in a mathematical terms, right? Let's say we have a pointer x here and a pointer y here, and x can go till minus k and plus k. Similarly, y can also go in like k units and k units. Let's keep it as k unit itself instead of getting us confused. So in a scenario like this, let's say we have 2 points and both of the points are uh, having a distance of more than 2k, then we won't be able to come to a common point where we satisfy our needs, right? So this is where 2k comes from. If the distance is more than 2k, then we won't be coming to a common point where we can do the operation and make the element into that position, or into that value. So that's what we do here. We are simply going to check if j minus I, jth value minus ith value is less than or equal to 2 into k. If it is yes, then we are going to increase our sliding window. We will increase our sliding window. In this scenario, 2 minus 1 is 1, 1 into 2 is 2, 2 is less than 4, so we increase the pointer. Well and good. Then we move our jth pointer one step ahead, and now we do the same. 4 minus 1 will give us 3, and 3 minus 2 into 2, 3 minus 4. Okay, wait. So 4 minus 1 is 3. Is 3 less than or equal to 4? Yes, obviously. Then we will be considering this position as well. So right now our sliding window is of this size. Now we jump one step ahead. Now J will be pointing in this location. Now 6 minus 1 is 5. 5 is less than or equal to 4. That is not the scenario. So what we do here is we try to shrink the window now. So let me erase a few things. So right now, I hope the mathematical derivation or whatever so-called representation was clear. So right now we are in a condition where J is in the last position and ith is in first position. The condition is not satisfied. So what you have to do is increase the pointer till the condition is satisfied. So ith pointer will be increased by 1. I will point to 2 right now. 6 minus 2 will give you 4. Is 4 less than or equal to 4? Yes, it is. Then well and good. Then we increase the pointer, jth pointer reaches out of bound, so we simply exit the loop. That's it. And every time you find a valid sliding window, then you will be trying to calculate the size of that window and compare it with the current result, and basically try to update the result. If you find a better subsequence, better valid subsequence of more length or maximum length than the current result, then you simply update it. So yeah, that's what we do here. So if you look into the solution, right, like I said, we have two pointers here, I is equal to 0, j is equal to 0. We are having a max size which is 1, because the solution that we will be providing here, what they say is the constraints. If you look into the constraint, right, we will have nums array with minimum of length 1 and maximum of length 10 to the power 5. So we are safe to assume that we can always have a maximum size of at least 1. So that's why I have declared 1 here. Then what we do is I have also declared a variable called count, and like I said, I will be increasing the jth pointer constantly. So you can see I have set up a condition here while j is less than nums dot size, and in every iteration we will be increasing the j's value here. And again now we will be checking for the valid condition here. If we reach a valid condition, if we are able to come up to a specific or special or common point where all the elements are same, then we increase the count was initially 0, ith and jth position are also in the same position. So let's say in this example itself, I and j are in the same position. 1 minus 1 is equal to 0, 0 less than or equal to 2 times of k. So right now the count is 1, and we update the maximum size as well. Um, and this go on until we find a condition where nums of j minus I is greater than 2 times of k. If that is the case, then we do an iteration and try to increase our ith pointer, basically the left pointer, in order to make a substring which matches the conditions. And after doing all of this, that right, we will be getting a substring or sliding window, or let us say a substring which is having all the values equal. In that scenario we will be updating the count as well, because I have moved my ith pointer, and we will continue the same. And after j reaches the end of array, then we are simply going to return our max size. And I actually did submit this solution and it got accepted. So the main the main crux of this problem is to identify what can be done with the hints that they have given. Hints in the sense, the solution that we are approaching, right? Can we take advantage of any of the statement they have mentioned here? For in this question, all of the elements for a special subsequence were same. That's the reason we were able to sort it and then do sliding window. or else if anything we would have had to do something like a DP. We would have done something like a recursive kind of solution, but it will give us a TLE because the constraints are kind of big. It goes till 10 to the power 5. So this is the optimal approach that we have come through. So I hope the explanations are clear here, and yeah, thanks for watching. Bye bye.